let's take a look at wind power, pumped storage, and solar energy. So the idea behind wind power is that wind is moving air. Maybe you don't think about it, but the air, as it moves, it has kinetic energy, or it contains kinetic energy. So if we build a wind turbine, the idea of the wind turbine is when the wind passes through it, the turbine turns. Now, when the turbine turns, that turns a generator, usually, in the wind turbine to produce electrical energy. So the whole idea is that we're taking kinetic energy of air and turning it into electrical energy. Now, a good question to ask would be, how much power could we get from a wind turbine? And we can determine that. The maximum power that you can get from a wind turbine would be equal to the kinetic energy divided by the time. Now, when I write the kinetic energy here, what I mean is that's the kinetic energy of the air passing through a turbine, and T is the amount of time that it takes for that air to pass through the turbine. So we can rewrite that as 1/2 mv squared over T, where m is the mass of the air that's passing through the turbine in time t, and v is the speed of the air as it passes through the turbine. So let's see, well, that mass could be written a different way, because mass is equal to density times volume, where this is the density of the air now, and that's the volume of air that passes through the turbine in time t. So if we draw a little diagram over here, kind of a cylinder, where this face is the turbine, or the area that is traced out by the turbine blades, and this length, that's the length of the air that passed through the turbine in time t. So now we can get an expression for the mass. The mass is equal to the density of the air times the area that is traced out by the turbine blades times L, where that's the length of the air that passed through the turbine. So we can put that into our power equation now. 1/2 rho A L V squared over T. And L over T, if we rearrange that, this L over T, that's the length of this cylinder up here. That's the length of the air, or the distance traveled by the air as it passed through the turbine. And that divided by the time, that's the velocity of the air. So the power, the maximum amount of power that can be taken from the air using a turbine is 1/2 times the density of the air times the area that's traced out by the blades times the speed of the air cubed. Now, that's the maximum amount we can get. Some energy is always going to be degraded in this process, and not all the kinetic energy is transferred to the blades. But this gives us a maximum bound for the amount of energy. And it also tells us a couple interesting things. Notice that the speed cubed is proportional to the power that comes out of the wind turbine. So the power that you get from a wind turbine is very dependent on the speed of the air. Also the area. The greater the area that's traced out by those wind turbine blades, the more power you will get. Let's move on to pumped storage. So this is a system where an intermittent or temporary source, like say wind or solar, is used to pump water to a higher level. And when I say higher level, I mean physically at a higher height. And then, when energy is needed, the water flows back down to a lower height through turbines to produce energy, electrical energy, which can then be used. So this is not a primary source of energy. This is a secondary source of energy because we're taking another primary source, an intermittent or temporary source like wind or solar. So let's say the wind is blowing very, very hard one day. So you're getting a lot of energy from your wind turbines. More energy than you really need. Then what you can do is with that extra energy, you can use that to pump water to a higher level, to this upper reservoir that I've drawn here. And then, later on, when the wind is not as strong, you can allow some of that water to flow downhill through a turbine, and that will produce electrical energy. That'll produce electrical energy that's not coming from your turbines that day. The idea of pumped storage is that you're using energy that you have in the moment to store it as potential energy of water in an upper reservoir. And then another day, or another hour, or another year, when you do need the energy, you can take the potential energy that's stored in the water at this higher height and convert it into electrical energy by letting it flow downhill through a turbine. If this seems like a strange idea, it's not too strange, actually. It's pretty common. It's used in a lot of different places. It has its drawbacks. You need to have an upper reservoir. You need to have a place to do this. You need a space to keep a lot of water at a high height. But if you have that available, it is a great way to store energy until you need it. Finally, we'll look at solar energy, and we're going to look at two different types of solar energy. First, we'll look at photovoltaic cells. Now, these are the kind of classic solar energy panels that we usually see around. And the idea of these is that they convert solar energy, energy that's coming in through sunlight, into electrical energy directly. This is done by using advanced materials called photovoltaic cells, or PV cells, and we're not going to talk too much about exactly how these work. But the general idea is that photovoltaic cell, set right there, if you have sunlight coming in, the sunlight will generate an EMF similar to a direct current cell. Another way of using solar energy is by means of solar heating panels. In solar heating panels, incoming sunlight heats water that is pumped through the panel. And then that water that has been heated by the sunlight then goes down to a heat exchanger and transfers that energy that it gained from the sunlight to, say, water, and it can heat up your water. So this is a great idea for hot water heaters in locations where there's maybe a lot of sunlight coming in. Now, I've drawn it with water going through the solar heating panel, but it can be used with a different fluid, one with different thermal properties that maybe is more efficient at transporting the heat. But the basic idea is the same. You send a fluid into the solar heating panel, sunlight comes in and heats up that fluid. The hot fluid then comes down into a heat exchanger where it transfers some thermal energy to the water in the heat exchanger, therefore providing you with hot water. Now, of course, photovoltaic cells and solar heating panels both can come in very different designs and have different variations. These are just two fundamental ways of using solar energy.